Hi there, folks. I know what you're thinking now. As soon as you saw that little device behind me, you said, oh no, not this again. Not the lazy Susan upside down salad bowl taped with weed whacker string lesson. Oh, I've had this every year since kindergarten. But I bet you haven't, have you? No, but I wanted to let you have a look at that first because that's an intriguing little setup. And has it twigged a memory at all? Does that device look somehow familiar or useful? By the end of this video, you will understand why that device is, well, the model. That's a model of a device. You'll understand why that device is so interesting, historic, fascinating, and special. But right now we have to pause for a second and look back a little bit at the start of the story. You could think of the start of the story right from here. What is it? Well, it's a crossbow. Again, it's really just a model of a crossbow. It's a child's toy of a crossbow, let's just say. But how does that crossbow work? Well, it uses a piece of wood right up here, which attaches to the what would you call that? The barrel or the shank of the crossbow, I guess. Attaches right up here in the slot. And then to the ends of that piece of wood are tied this string, right? And right now the string is actually cocked. It's ready to fire, almost. Now it's ready to fire, right? Before that string was in that position, of course, it looked like this. There was much, much less tension on that piece of wood. But as that string was pulled back, you could see that the wood starts to bend. See that wood bend there? As I pull the string back, the wood bends. So the wood is acting like a spring. Of course, the wood doesn't want to bend. The wood wants to be as straight as it was when it was a tree. So as I pull it back, I'm putting spring tension into that wood. In this case, I just loop that little string around here, put my arrow back here. If I fire my trigger, of course, that string will flip that little arrow along, and that's how I fire my crossbow. Okay, but I want you to notice this. How do springs work? Well, you load them full of energy, and then when you let that energy go, it will send that energy into something. And notice this also. If I pull the string back a little, that wood bends a little. But if I pull it back more, the wood bends more. And of course, the more I pull, it's getting harder to pull because that spring force is really getting strong. Goodness, I've got tons of force built into this now, right? Much more than I had up here. So the more I pull on that string and the more I bend my spring, the more potential energy I put into it. So right about now you're saying, all right, so what? Well, here's the so what. If you're powering a clock, you've got rather a problem on your hands. Here's why. Because you can't fit a long piece of wood sideways in your clock. That's not the type of spring you need to use. How do you power a clock? Well, you use a rotational spring, a coil of wire that looks like this. Now I've taped that end down, you see. So watch, as you crank your clock up or wind it up, you're turning that coil of wire inside. And of course, it springs back, right? So you click, 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 you wind it up like that. And as it slowly unwinds, it's pulling this end around and around and around and unwinding. Here's a back of a clock that uses a wind-up mechanism. You can see it's actually an old chess clock. So you wind it, tick, 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 wind it up, tick, 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 tick. There it is right there and there. There's my little clock working. Oh, that's a sweetie pie. But remember, the more I pulled that piece of wood back, the more power I was putting into that spring. So at first, when the string was up here, it had very low power. And the more I pulled it back, the more the power got. More, harder and harder to pull. So that string was pulling against me like crazy. Well, unfortunately, it's the same with the rotational spring. If I wind it only once or twice, tick, tick, it's not hardly pulling at all. But if I wind it a whole bunch, tick, 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 It's pulling like crazy. Well, that became a very big problem. As soon as I began to use that in a clock and try it, it was terrible because if you first wound up the clock and you wound it all the way, the spring had all kinds of power and the clock ran super fast. But as the spring slowly wound down and got weaker and weaker and weaker, the clock slowed down. So the clock ran fast in the morning and slow at night? That's not a clock. Do you know what you call that? Useless. You just can't use that for timekeeping at all. So the early clock makers that were trying to use a spring of that type had a very big problem. Everything else was worked out fine. The hands were fine. The dial was fine. The gears were perfectly. They had it all worked out in a scientific sort of way. But the power source was the problem. How can you get a spring to give you the same pull at all times? Are you ready for this? This is amazing. Here's the answer, and the answer is absolute genius. You see what I just did? I just put that crazy machine I showed you at the beginning directly on top of that spring. What in the world is this? Lazy Susan, upside down salad bowl, and weed whacker cord? Well, you're going to have to use some imagination right now. But that's basically what the design was. Some genius, and the name of this genius unfortunately has been lost. It was a genius sometime in the 15th century, the 1400s, said, look, here's how you do it. You stick with your spring as it is. Keep the spring as it is, right? It's just that the spring can't run the clock or the watch. It can't do that. What you have to do is have the spring run this device. So instead of winding up the spring, you wind up this. Tick, 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 tick. 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 Right? It starts with the string attached to the top. And it slowly, as it tick, tick, tick winds up, rolls the string all the way down to the very, very bottom. Okay, so when the spring is fully wound, oops, stop little baby. When the spring is fully wound, the string is down here. Well, what does that mean? How does that make any difference at all? Well, instead of running the clock with a gear, the clock or the watch is run with the pull from this string. Okay? So the clock or watch's gears are pulled along with a cord instead of directly driving the gear. But I don't get it. What's the upside down bun cone thing? How does this make any difference? How does that take away the problem of the weak and strong spring? Leverage, my dears. Leverage. Remember your grade 2 and 3 science? 3, actually. Look, when the cord begins, it's very, very close to the center of the axle, which means the cord near the center of the axle has a different power than when the cord is much, much farther away from the axle right here, right? If that spring were pulling right now, it would have a much weaker pull right here than it does at the very top, right? So it would pull very, very strongly when the cord is near the axle, has much more leverage. It's like a smaller gear on a bicycle, right? Pulling me. And as the gear unwinds, or as this part gets bigger, the power of the spring changes because you're getting farther away from the axle. So really what happens is I wind this up, and then this little baby keeps pulling my clock along and slowly unwinding till it gets to the top. Oh gosh! Oh, my science experiment just destroyed itself. Unwind, 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 which of course is changing the power of the pull of that cord. It's using the leverage principle with the spring to make everything even out. What is that, you say? Not interested in salad bowls? You want to see a real one? Of course, I've got a real one to show you. Oops, Where is it? Well, it's in my pocket. Come on, real one. Oh, here we go. Oh, gee whiz. Here it comes. Suspense. Look at this one. Come on. How's that possible? You mean the upside down salad bowl and Lazy Susan's inside here? Yeah, it is. Unbelievable. We have to take this little baby to maybe a brighter spot where I can lay it down, and I'll show you the upside down salad bowl inside this little watch. It's actually called a Fusi or Fusi. Alrighty. And there it is. Now I've opened up that little case. It's got sort of a butterfly design case. There's the back opened up on the left and the front glass opened up on the right, and the movement hinges out. And right now it's actually sitting on top of its special dust protector back here. Now I've got a ballpoint pen, and I'm going to carefully try to zoom in right here. And I think you'll see the lovely ornate handmade movement. This particular one is made a little bit later. This is an 1842 design made in England. So where's my pen now? I'm trying to look through my viewfinder here of the camera. Oh, there's the pen. Oh, there it is right there. Okay, so there's my tip of my ballpoint pen. I'm going to slowly and carefully bring it up. And I'm going to point to you right there. Do you see it? I'll get a little bit lower. There it is. Do you see the salad bowl there, that cone? I'm going to get a little bit closer so you can see it there. There it is there. Okay, so that cone there is exactly the same design as the salad bowl I showed you. And you can see that not only is it a cone, but that cone has little like jumps. It's like a little concentric spinny thing with a little like rampy road that goes to the top. So it's not smooth, right? It's got those little tiny bumps that go up to the top so that the cord actually sits in there. Now the video right now for today is going to stop. I've got a bit of news for you about that cord. Tomorrow's video is going to be about the cord because I want to show you that the story's not even over yet. The beauty of that movement is, of course, sensational. And it still runs, that little honey bun, 100 and however many years it is now. 170 something years? I'll have to do the math when I stop the video. But what is most amazing about that design is not just the idea, it's how it was put together. Because that little cord is made so beautifully. I want to show you how that's done, and that will be tomorrow's video. But I hope you enjoyed today, and I hope you appreciate this lovely little piece and this wonderful piece of genius as much as I do. Let me flip that back up carefully. There it is. Isn't that a little beauty? Just a wonderful, wonderful, wonderful piece of engineering. So teensy-weensy. Unbelievable. A very special piece in its day. Hope you've enjoyed it.